Hi there, Jacques Droussard here. I'd like to welcome you to my fourth programming screencast for Computer Science 440. As per usual, in this video I will be walking you through my code and focusing in on some of the key aspects and, of course, finally demonstrating the game. However, for this project or assignment, there were some additional, or I would say extracurricular design elements, and I'm going to be taking some extra time to go over what that entailed. So, more about the assignment. For this game, we were instructed to make a side-scrolling hedge-type game. The player was supposed to go through 3 levels, each one timed to 60 seconds, and we had to come up with a unique theme separate from previous labs we had. So with that house cleaning finished, let's begin. Alright, well here we are in Microsoft Visual Studio. I have to make a confession here. There's an additional bit of house cleaning I need to do. For this assignment, we introduced a new piece of software called Mappy. It's a freeware map editor. So you import a tile set and build levels with it. It handles a lot of kind of tile, attaches variables to tiles essentially, and builds the 2D array that you would have to do by hand if it weren't for this program. And in between Mappy and our source code, there's a library called Mappy A5, coincidentally. And it's tying the Allegro library to Mappy, which ends up getting dumped into our source code. So I will demonstrate Mappy after we go through the code. It's beneficial. It's necessary to explain that I'm going to skip over some stuff because it just won't make a whole lot of sense until you see the program. Now, I don't like to waste too much time on header files, because all the good stuff is sitting right here in our C++ file. So this is the Sprite class. We have our necessary but kind of boring constructor and deconstructor, and here's our initializer. So let's talk about this. This is initializing the position in which the player will be, like the spawning location on the map for the very first level. So remember, there's 3 levels, and that will be changed later on. I'll explain that later. Now these have to do with the animating of the sprite, the animation of the sprite. So before we go any further, let me just have you take a look at my sprite sheet so that we can further explain how the sprite grabbing and the animations taking place. Okay, so here's my sprite. I took my theme from Final Fantasy. One of my all-time favorite games growing up was Final Fantasy IV. This is an NPC in the game. It's like a giant chicken that some of the that you can it's like a race of giant chickens, and they're helpful to you. So you can ride them like horses, and I think at some point they let you fly around with them as well. So anyways, I'll go into more detail about asset building and all that, but the important thing to note right now is the configuration of this sprite sheet here. So we have the bird facing towards us, the bird facing away from us, and then the bird facing to the left, set up in rows. So these rows denote the direction, or the animation direction. So forward direction, backwards direction, lateral movement directions. And the columns are the different frames. So we have frame 0 is, let me start over here. So row 0, column 0 is chicken or chocobo with right leg up, and row 0, column 1 is Chocobo with left leg up. And this idea is pretty much just mirrored for the next row. And the bottom row here, since we're talking about lateral movement, forgive this lazy and terrible pun, but we're getting two birds with one row, one stone, essentially. Got that reversed. Essentially one row. We're getting two birds because when we print the particular regions of this sheet out, we'll just use a particular flag, which is going to mirror this bird so that it's pointing in the right direction. So that's the sprite sheet. We can go back to the code now. Okay, so now that we've taken a peek at the sprite sheet, these next variables are going to be a lot easier to explain. Now, luckily for me, I took, it just so happens that my sprite sheet was very simple and very even and very squarish. So in any direction, it only took 2 frames of animation to make the animation believable. So this max frame value is set to 2. If I had uneven number of animations for any one of those directions, this would need to reflect that, and it pretty much helps us prevent an animation that would be longer or shorter messing with our printing of the animation. So that will become clear when we go into the draw function of this class. The current frame we've seen before, just whichever frame we're currently printing. The count and the delay are used in a loop, in a for loop, to help make our animation believable. So instead of cycling through our animation at 60 frames per second, which would make our Chocobo look like it was on drugs, we delay it by, I guess this would make it 10%, so that our animation is believable while we're pressing the key down. The width and height are necessary now because we're using a sheet and we're not using individual images for the animation. So we're taking the sheet and we're telling, we need to pump in these figures so that we know where each square or each image, each iteration of our sprite ends. So this, if we were to think about our sprite sheet as if it were an array, frame width 24, frame height 32 represents 0, 0. And if we were to just move over to the next one, that would be increasing the width, so we would keep our frame height, well actually, yes, 32, our frame height would be 32 and our width would be 48. And that would just go over, so we would have the Chocobo with its that would be its left leg up. The animation columns and the animation columns is explaining the sprite sheet configuration. Obviously you saw that there were 2 columns, and the direction is, this is just initializing which direction the Chocobo is pointing when it gets printed to the screen for the very first time. Loading the image, and we don't really need this because it's a PNG. I think this is just vestigial from the lab. Let's see here. Updating sprite. So as before, this is really taking into account the position of our sprite, our Chocobo, but it's going to handle the additional function now because we're paying attention to the direction, and we want to pass in which frame we're printing to the draw function when it comes up. So in kind of like the order of things that happen in the main program driver is that we update a position and then we draw it. Next frame comes in, we update its position and then draw it. So here we're reading in the direction, so the key that's being pressed down. So if we have the button, the right arrow key pressed, we know that we're advancing our X position by 2. And the opposite if we're doing it on the left, which would be subtracting from whatever our position is to 2. This is just, so for every motion we do, we're taking into account the frame delay here. So as we're moving along, we're waiting for our 6 frames to pass by. Once those 6 frames have passed by, then we actually advance the current frame, so that we're actually going to the next column. Or we're telling the sprite grabber, okay, time to advance to the next column. So that's the way that my sprite sheet is configured. Is row denotes direction, column denotes or column number denotes which frame of the animation we're printing. The up and down updating is exactly the same, except we're just, we're watching for a different direction, obviously, and we're updating the Y position of the character. So there's no diagonal movement here unless you tap the keys very quickly, but the variables are changing one at a time here. So decrementing to go up and incrementing to go down. I know that sounds kind of counterintuitive, but in the graphics world, our Cartesian plane is set up 0, 0 being the upper left-hand corner, not the lower left-hand corner. If you're not moving at all, we just remain in the same direction, or we don't. Yeah, the animation direction has not changed, so we don't want to have a default position. Just whatever it was last, keep that direction. Our collision here, okay, so I skipped this in the very beginning, and I made something similar to this in one of the earlier labs of this week, because I didn't like that bumping or that vibrating action, kind of that rubber band action when you would run into a wall in some of the earlier games we were making. And it's a pretty simple concept. You just, every update, you just remember where you were, and you do not allow any change if that collision is detected. So you don't before, if you just say, oh no, just set X to itself or whatever, don't allow it to advance, which was how we had it before, you would get this bouncing action. It wouldn't allow you to advance, and it would just reset you back to your old position. Okay, so that sounds funny, but the way to fix it is just to remember what it was and don't allow it to change any further if you reach any sort of collision. Does that make any sense? Anyways, that's all that this entire if-else suite is doing here. It's just accounting for the collision. This collision end block pretty much ended the game in the labs, or the demo in the labs. So not to just completely bite off it, I decided to build them, well, I wanted to expand it and make like teleportation blocks, collision TP and collision next level. Not making the same mistake I did last program is I detected when I was kind of taking on too much with the amount of time I had remaining. So TP, as kind of a lazy slob, I apologize for that. This should be my end block. I just converted, excuse me, I converted it, the TP, to become my end block. I didn't want to reuse these. I wanted to write from scratch the code so I could completely follow this TP value, and especially because one thing I passed over here in the HC was that these friend functions, I'm not the best with C++, and so this ID of a function called friend, it wasn't very clear to me what it was, and now it is, and the only way I was going to learn that was by just obviously Googling it, and then through practice copying word for word, not just doing a copy and paste, like word for word it, and kind of talking to myself as I'm going through it, like, okay, now I know what variables I'm passing through and for what reasons. So even though it doesn't make sense that it's TP block, this is actually my end block, and this one makes sense, it's my next level block. So in MAPI, and I'll show that to you, I'll demonstrate that later, is that some blocks can return particular values, and in MAPI they're called user with a number. So these we just search or check these variables every frame, and if they return what we're looking for, which these will be explained in the main function, then we'll set this function to return true, and we know, okay, our sprite is currently on the next level block, or our sprite is currently on the end of the game block. Okay, so on to the graphics. We're drawing our sprite now. The FX and FY, as you can clearly see here, is denoting the animation. The X and Y kind of location of which sprite we're drawing, or which region of the sprite sheet we're drawing. Ooh. Okay, excuse me. So to reiterate, the configuration that I had was direction by row, animation frame by column. So as we dig deeper, we're going down the rows, so this is showing us which direction. So on if we go down 64 pixels, that's the start of our left and right, which is what was the bottommost row. 90, the next frame over, so the 96 is the bottom of that frame, or the bottom of that square, but we want the beginning, so we want the upper left hand corner of the frame in which we're going to be grabbing. And since we know that the direction is not going to change throughout the animation cycle, we just hard code it in. So okay, it says 64, but really what I'm thinking is row number 2, row number 1, row number 0. And then the X is just being calculated by the current frame, by the animation columns, and then obviously it's being controlled by the update function. So it's not being allowed to advance until the delay has been, the delay threshold has been met. These are set inside here and then just passed into the draw bitmap region. So we're no longer calling just draw bitmap, which is more intensive to just call in a different image all the time. We're calling in just one image every single time, and we're just grabbing a little chunk of it. This doesn't change because this is kind of like our starting location and the end location of our grab, and then the physical location of the entire frame where it's being printed. So this function wants to know what image, where's our sheet, which square on that sheet do you want me to grab, and then where do you want me to put it on the screen, and then any flags if they exist. Here's my 2 birds, 1 stone. So we're pointing row 2 no modifications, which means this is turning to the left, this is turning to the right. Same thing, just flip it. So pretty simple, easy to follow. And same issue, same concept here. We're just it's just being, our animation directions being given to us as 2 and 3. This was probably the most time-consuming function to edit. It was actually the most fun. I learned the most here, I think, because I think it's kind of harder to conceptualize a lot of this stuff until you actually see it being printed. So I guess you call me a visual learner. And I inundated this whole thing with cout statements, and as I was practicing and moving the sprite around, I could see all the different variables being updated, and it was very cool to see the sprite, flip between the 2 frames and see those numbers go, you know, 0, 24, 0, 24, 0, 24, 0, 24, and then, but actually seeing the position moving, in the hundreds and then in the thousands, as it was moving around the map. So that there was something pleasing and mechanical about it. It all very much came together with this. And I kind of left that to remind myself to talk about that. It serves a dual purpose as well when the maps start to get larger and more cumbersome. So obviously you can just use Mappy and count the tiles and multiply them by your tile set size to give yourself an idea of where, the locate, if you want to place things, print things on the map in particular locations. This was really helpful because in the very last level I print like your friends, so copies of this sprite, and during testing another twofer, I just moved the character where I wanted while I was testing the collision detection and things like that. I moved the character where I wanted the friends to appear, and I just wrote down all, so I had the direction and the position down to the T. So that was that kind of additional functionality out of this function here. To keep things fresh, if that's fair, I needed to build these two setters for the actual position of the sprite printing, so that when the next level started, the bird didn't initialize to the same place every single level. So I started one in the upper left-hand corner, the next level in the lower right-hand corner, and then the final level back in the left-hand corner. So I needed to introduce or build these two setters. Alright, so I know that's pretty dense, but there's only one more file to go, just as dense, and then we will be on to demonstrating the game. So let's move on to source. Alright, so here we are in our main. Our includes pretty run-of-the-mill, nothing interesting there. I mean, aside from we're including the Mappy library. It pops up a few times, and I'll point it out when it does. But here's like my most favorite part of at least coding the source file were the main functions. I think there's the most freedom in here. You get to kind of decide how you want to tie everything together and how you want to pretty much implement, the mechanics of the game. Not like the internal mechanics, but kind of the outer shell and how you're going to wrap the present up, let's put it that way. And as these classes progressed, I've felt more confident to do things, at least I'm thinking, oh, this will be clever to do it this way. And then I realize, oh man, I've gotten myself into some, as you can see, like, take a look at this one. Loading the next story cards turned into, yeah, you're passing in quite a lot for just a little bit of work. And I kept it only because it worked well. And, I mean, I plan to take this theme and this concept into the very final assignment and just add a bunch of features and build on this. And this will probably, I'll keep the idea but clean it up a lot. So anyways, that's what I'm trying to say, is that the freedom, this is, I guess, where you get to really express yourself most in the source. A lot of this kind of stuff here is the repetitive. Oh, well, this is kind of the implementation that's used most commonly, and it's the most effective or whatever. So these will come at the end, and I'll spend the most time on. I'm kind of burn through this stuff because there's not a whole lot of new stuff here, right? So we're just setting up variables as usual. Some are for your display, some are for your keys, some are for timekeeping. These are just to space lines in between fonts that get printed, so I'm not changing it in every single one. So if I decide to change the font I just have to modify the size and then the line spacing so it looks great. I don't have to go around changing every single one. Kind of Computer Science 101 there, using variables instead of hard-coding stuff. And then boolings to control my loops here. So this is the game loop. This is for rendering your graphics. Yeah, so this is actually the only loop control. All these are just if-else statements that trigger certain events. So this is for rendering the graphics. This is for pausing in between the levels and presenting the player with a new card with new information, like a new prompt. This is for finishing the game, so it doesn't know whether you won or lost. I need to keep that separate for getting the winning and losing cards printed correctly, or at the right times, or the times that I wanted them to show up. And then this is just telling you whether you won or lost. So obviously the time is going to trigger this, or arriving at the correct, on the right tile. You know, right? Creating the player object, our allegro objects, initializing the library, our display, getting the font set up. Here are some other add-ons we're going to need: keyboard, image, primitives. Here we're initializing our player. So that was all the initial location. So this is where you show up in the first level, and then for animation, and then actually loading in the picture or the sprite sheet. Initializing our offset. So we need to take account for the additional of where the camera is pointing, essentially. So as we move further down the map, we need to move the camera, and that's what these variables are for. We load the first map, set up our event queue, register our event sources, and start the timer. I like to call this prepping the screen, where we like print the very first items onto the screen. So this is a mappy function. We draw the background objects, we draw the foreground objects, get the player on the map, flip the display, and then clear the display for the next time we flip it. Or, you know, we clear the canvas for the next print. This is to initialize the animations, or any tiles that are animated. So in mine I have like some jingling fruit and some shimmering water. Here we're loading our winner and losing cards, so the screens for winning and losing, and then the NP. So I use the same sheet for your buddies that you meet up with at the end of the game. Alright, super. So we've arrived to the game loop. While not done, this one's never getting old, but why change something that's not broken, right? Here is the is paused boolean, which stops you from pretty much stops the counter, presents you with the prompt and the story, and then waits for your key press to start the game and to start the clock. So yeah, these are all going. I'm going to go into detail at the very bottom where these are, where the implementations are explained. Game clock, I pretty much just took this from program number 2, I think it was, the concentration game, and I just subtract 60 from it and set it to a brand new variable later down, right before we stuff it into a font drawing function which displays the time above the character at all times. This, again, almost didn't change at all from some of our other earlier labs. We create an event object. We call this a wait for event function, and so for every frame we're doing these things. We're updating our animations. And by the way, this is part of that mappy thing again, the mappy library. We have a delay variable or a delay mechanism for our sprite animation. Mappy has a little box where you put in that figure, and then it will delay the animation of our tiles according to that. So that'll come up when I demonstrate mappy. But just to show that the idea of delaying animation or not syncing your animation up with your frames per second, because it's just, I mean, you're running through so many frames per second, it makes the animation unbelievable if you want to get it done in any reasonable amount of frames here. I mean, we're not talking, we're talking, 32-bit kind of graphics, or maybe even less for some of these games. Not necessary to go through at 50 frames per second for the animations, at least. Alright, so, right, we're just, here are enums for the keys. I'm sorry, we're updating according to what we're pressing. Every frame we check for our collisions, whether we're hitting not a generic collision, but whether we have arrived on the end block or the next level block. You can see if we hit the next level block, if it returns true, go ahead, increment the level variable, and then pause the game. It goes back up here, and then these things get passed into, okay, so new level, and then this is for updating the player's position. We pass in the player object. Keep the key values to true when they're down, false to when they're up, and move the camera accordingly. So, which is our player position plus the width of the actual, I'm sorry, the sprite, and then so we're essentially keeping the camera centered on the player at all times. This is camera collision, I guess we can call it, keeping ourselves focused and not flying off into the black abyss. And here we get into like kind of I like to call this like the drawing suites, the drawing functions. So every frame, go ahead, draw our background, draw our foreground, draw our player, display. So here the time gets updated. So the time left is equal to 60 minus whatever the game time is at. If it's at 0, go ahead and finish the game. The win condition is initialized to false, so and that makes that part easy. We just close it up and it'll show up as we've lost the game. Still here with the drawing. If we're at level 4, so I missed something in testing, but I had to advance the level an additional level because it was printing the NPCs too early, like in between 2 and 3. So the problem is that this gets passed in through one of the cards. Anyways, you'll see that mistake when I demonstrate the game. But yeah, so if we're on the last level, draw the friends in the very last position. So I was talking about how it made it easier to find the exact locations on maps, so that's why I had that printout statement on in the sprite class right here. So these got more extensive. I printed everything so I could see everything changing as I was moving the character around. And it made it real nice and easy to just copy down what I needed to plunk, or to draw the sprites where I wanted them. So we're just jumping out. If the game's done, go ahead, jump out of the game loop, and since the playable part of the game is over, we're still in the program, so we just print out the last thing, right? We print out either whether they've won or whether they've lost. We'll eventually come to the end here, jump out of this, flip the display so we can see these, and then we wait for 10 seconds, turn everything off, delete all the memory, free up the memory, excuse me, and return 0. So we're done. Okay, let's take a moment and look at main functions. Collided is our generic collision detection. End value is our true-false, so we're returning a boolean whether we hit a tile that returns the user variable as 8. If user variable Okay, let me restate that. If the block object from Mappy has the field user1 and it contains the number 8, set return true. I chose not to use end value. I used this TP value for my end block. I think I'll have a teleport function for the final project, so I just got a little head start on it. I set it to return 9. If it returns 7, that's the next level. I started to think about this further. I think I want to try and think about developing this and just combining it all into one function where we can just check for any condition, and maybe have a helper function that looks for each of these numbers, and so maybe like a factory kind of pattern instead of just building an individual function that returns true for each of these conditions. So we'll see how that all works out next screencast, next project. Here's the one that just displays the little time above the character's head. So we get our font, the color, where our character is, and center it, and then this is kind of like it's a text function, so we're importing a variable into the text. What is this? This is the load next map. We get the level number, which is the switch case. Okay, so for 1, 2, 3, we load the appropriate map and we set the spawn location for the player. That's why it's passed in by reference, not by value. This looks a little chunky. It doesn't do a whole lot of lifting. It's just printing a lot of stuff on the screen. So it requires quite a bit of information to do that. Graphics is funny like that. Also, you'll see that I have kind of doubled up on the event queue and event object, and that's just to allow us to wait for that event, or a key press, escape or whatever, to close the story prompt and to begin the next level. It seemed a lot cleaner to do it this way instead of passing everything. I mean, you can already see how much I'm passing in. I thought that the event queue and the event object better it stay in its main game loop than join, into these like sub kind of main functions. Anyways, this will all show up kind of in the game, so I'll just kind of show you there, but it just gives you the, we're passing in the we're showing you which level you're on, giving you a little story, and then prompting you for a key press. Resetting the clock, this is, what? Computer Science 101, again, it's just, we're resetting our variables, 0, 0, 0, time left to 60. That is for pumping into this suite of code. Where are you? Right, there we go. For each level. So each level we have 60 seconds, that's why it needs to be reset. Alright, so enough of the code, and let's get to the fun part. Well, coding's fun too, but let's get to the part that you're probably waiting for, which is the game demo. Okay, so here we are. Got the game started. Two things before I press any keys. One, I need to give you a small disclaimer about the complexity of these maps. It is paltry. Let's just be honest, it's pretty sad. In the assignment prompt, there wasn't anything concerning the complexity or difficulty of the maps, so I chose to focus as much as I could on developing the assets and the code itself, and in a way sticking true to my theme. So don't expect these maps to be like Inception type, build a complex map in 2 minutes kind of good. I didn't want to get into the theory of map building. I wanted to stick to the goals of this class, which are graphics and game programming in general. So, the theme, right? Final Fantasy II. Number 4 by the Japanese numbering system, was my childhood all-time favorite Super Nintendo game. I must have played and beat that game dozens of times. And I loved the universe, the lore, the story. I could like really get lost in there, imagination-wise. So one of the NPCs is a race of giant chickens, birds. They're called the chocobos, and they're like helpers for you. So you get to ride them like horses, and I think certain breeds of them fly. You can use them to fly around the level faster, and I think there's some other ones that give you like little perks and things like that. So they're just like helpers along your quest. And I chose to make it the main character of this game, and in kind of the spirit of the nearing of the end of the semester, I chose to give the Chocobo a semester end beach party. So let's begin. Excuse the lousy font here. That's level 1. Looks like a B, but that is a V. So level 1, a Chocobo end of the semester beach party is being thrown, but there's only a limited number of guests allowed. First come, first serve, naturally, right? Look for some jumping peppers. Better hurry. You know, cute, kind of useless story part being developed here. And the very last lines I've tried to put like a hint. So something to look for, what the end tile might be, and here's the kind of indication that the time, you're on a time limit here. So I try not to, I didn't want to make the rules like, you know, oh, here are the rules of the game. I think that's boring. I think it's better if you code it into the story somehow. Okay, so let's begin. So here's the main character, Chocobo. Gender, male, female. I didn't decide on a gender yet. So it appears to have the correct animation, and it is colliding with the edge of the map as expected, as coded. And you can see I can't go diagonal. I have to tap the directions like this. So that's shows the fact that we're only updating one value at a time. Another point of the assignment was to build animating tiles, which you see right here. Some dancing peppers, and let's go and hit them before time runs out. Alright, level 2, you've managed to leave the treetops. If that wasn't clear, that's where you were in the first level. Great. If you plan to make it in time, you'll have to make your way through the beachside cavern. Look for a ladder. That's a pretty obvious hint. Let's go ahead and start this one. So you can see, like I was saying, you're spawned on the other side of the map. I thought that was kind of a neat... it's a subtle, but it's something different. It looks like you're walking through these things, but you're not. They still act as collision. What they're doing is it's kind of the animation of the frame. It's only detecting kind of like the middle of your frame, not the top of the head, which allows for kind of being able to maneuver diagonally through one square spaces a lot easier than if I actually had to go all the way here and then stop and then press up. You know, that would just be, you know, somebody might call it challenging. I'd call it obnoxious and not fun. So obviously these are simple, but I still know the best way to go. So let's climb up the ladder and see what the next level is all about. So my little Jimmy rigging plan to not print your buddies on level or on the in-between phases backfired. So now I have level 4 instead of level 3 here. Anyways, see, if I didn't have the 4, and I needed to come up with a different mechanism to prevent the buddies would be printed right here, where they end up being relative to their end location, relative to the screen position. And so when I incremented it to level 4, I used it kind of like as a flag to say, okay, now you can print them, but I must have done it too soon because it's yeah, too soon because it's obviously being carried over into this screen. So bad on me, but small detail. You're almost there. You can even hear the party. Don't get lost or stuck on a sandbar. You start to remember how well you can run through dry bushes. Another clue. Here we are at the beach now, so we have some enticing kind of like a direction stars, but I know that's not the way to go, so we're going to go the right way. Check out this cool little bridge I made, and avoid the cactus. Stars you can walk over, and hey, look, a dry bush, and that's right, you can run through them really well. We keep on going. This one's kind of the last level, sort of the easiest one if you follow the hint at least. And there are your buddies and some dancing tomatoes, I guess. Well, they won't be dancing soon when you eat them. Anyways, again, the collision detection. There's some animating tiles right there of the shimmering water. And I guess so. Let's go ahead and win the game and see what those winning cards look like. Winner, winner. No chicken dinner, but still a winner. This waits for 10 seconds and then closes. I will reopen the game. If I remember anything to tell you, I will. But I'm going to allow the character to time out so that you can see the losing screen. Oh, you know, I might as well show the different directions at least. So you sort of saw what this was easy. I mean, you can kind of tell. Oh, dead end. Turn around. Let's keep on going. Now, as far as the complexity and that going along with the theme is, if you've ever played at least Final Fantasy II, is that not until like the very end do the maps get big enough where you really start to get lost. I mean, they still take time to go through, but I wouldn't say that they're, you know, like I use the Inception idea. They're not like crazy, you know, you need to get lost in them kind of maps. So I think there was like one map where it was made on purpose like that. And so here's a little trick I put in the map. Oh, it's the same color, so that's the trick, right? Haha. I mean, there's a stone here, but make you think like you can't go through this, and make you believe for a split moment that you might be able to pass through that. So yeah, I think there was like one level in that game that was a bunch of like a mirror castle or something, and it was like purposely made so that like when you went into certain doors, it just boomeranged you back to the beginning. But for the most part, they were all fairly simple maps. So here we go. This is the challenging part. So that looks weird again, but that is collision. And this is not collision. This is collision here. There's collision. Collision there. No collision there. No collision there. So like it was kind of a guessing game. Oh, are you going to get stopped by this or not? You know. So that was the challenging part, I guess, of the game. And obviously there's collision there. And I believe I let you go through here too. Yeah. Okay. So you can go through here, and then this is that little diagonal thing I was talking about, being able to travel through there. That would be a pain in the you know what if you had to do one of those. So anyways, I could make it in time, but I want you to see the losing screen, so I'm going to be antisocial and go hang out by myself at the beach's edge here. Oh, sad Chocobo, sorry you missed the party. Alright, so that concludes the game demonstration. I know this video is getting long, so I'm just going to buzz through the development part, so hang tight for that. Great, okay, so let me restart. Okay, so here we are. We're going to take a look at some of the supporting software. For starters, Mappy, which was the more important one. So Mappy is a map building software where you start off asking to make a new map. you explain your tile size, or you have a tile sheet, which is like a sprite sheet, but it's for the tiles of the game. You tell what kind of size each of your tiles are, and it splits it up accordingly, and then how big you physically want your map. And then here they're asking you for the depth of color that you're going to be using. Now, we were kind of led to an additional tutorial to help us use this program. It suggested we just ignore this advanced option. I discovered there's some pretty cool stuff in here, so I want to go over that. If your tile set contains more than 1,000 tiles, you're going to need to update this FMP version here. Secondly, this tile gap, the staggering here is really helpful because it's not like there's an IEE standard out there for tile sets. Artists just go out there and make them. So you saw in my Sprite Sheet, or actually I can show you right now how it looks like in GIMP, because it's a lot more easier. It's a lot more easier? What is that? It's a lot easier to see kind of the placement. So let me bring this up. So you can see that each of these, so each direction was a GIF file. Professor Pollack had shown us a website that extracts each frame from the GIF file, and I just simply took each frame and created, found the size of one iteration of the bird, multiplied that, built the background of the appropriate size, and then slid these suckers in the correct position. You can see this one's still selected here. They weren't all the same size, so I had to do a little scaling to get it so that they're all, I believe it's 24 by 32. Now you see that there's no separation here. I don't use a line or nothing, so when I give those dimensions to the sprint grabber, it just right on the pixel, these things are being grabbed. Now with this offsetting function or setting here, you can account for any sort of dividers that artists might put into their sprite sheets or their tile sheets. There were a whole bunch that I saw and tried playing around with, but what happens is when Mappy separates these into tiles, if there's any sort of separator, it starts to inch over, because you're not accounting for that 1 pixel or 2 pixel separation, so your tiles become off center. It becomes very obvious very quickly, like after maybe the 10th tile, So I thought they were unusable, and I thought, oh, maybe there's a different editor these things were built for, but no, there's just this setting. It was just hiding here. By the time I found it, it was already too late. So for anybody, using this program or whatever, this might be helpful for you. Okay, so I just started a new one unintentionally. Let's go back to looking at our levels here. So this side of the screen here, this one that's flipping back and forth, this is called the tile editor. And for this map, we're in the treetops. So let's take a look at the tiles I use. So like this tile here. You double click it, it opens up this block properties screen, and here's the kind of important things about it. This collision checkbox here is setting like a flag for the collision. So it seems pretty intuitive, right? Like TLBL, TRBR as being top right, bottom right, top left, right. And you would think that would be like a directional kind of collision, but I messed around with it and experimented with it, and it turns out that's not how it operates. In fact, the way that the function that we use is just looking for this value. Whatever this returns, if it returns true, the entire square is collidable. At least in my program, that's how the function works. I was looking at someone else who had a tutorial using Mappy, and they built a racing game with it. And they were explaining how they used these values, and what happened, or how they used it, is if they had a collision function that returned both of these functions, they would say that you know, this is a clean road, and you know, your acceleration's optimal, and if you have this collision, then you're on, you know, like a bump, like the dirt road on the side. And that is to say, you know, you have some helper functions that say, you know, affect the vehicle's speed, and then make it like vibrate so it's bumpy, you know, when you draw it. And then, like, say you wanted to go through like a muddy patch, well, you would turn on this square, and when this one was being returned, it would keep the vibrations and the speed, but it would also introduce like a slippery function, you know, so that you could set it up like this, where you're like, oh, I'm on good road, but it's slippery, like it's raining or something. So you have your optimal speed, but you know, the car doesn't take turns as well, or something like that. So it's, while I'm sure there's a way to get it to work where it's like you're actually looking at the corners, I think this is more just, you know, this is additional functionality that Mappy allows you to use, and you can kind of determine how you want to use it. I thought that was really cool, and that tutorial helped me kind of understand the connection between Mappy, the library, and the Mappy library that connects it to Allegro. It helped me understand it, understand it a lot better. So that's collision. Let's look at animated tiles. Okay, so great program. I have one, like, rather a big complaint about this though. When I was messing around with these animation or any tile properties, as far as like the reference images or inserting the animation tiles, so if it isn't apparently clear right now, like this reference image is just what is printed here in the editing kind of main window, not what actually gets printed in the game. So you want to set this so you know which one you're talking about, right? So you click this and it gives you this, which I thought was just insane. Why would you have a program that allows you to, you know, have a dynamic window like this, and with these, you know, we see some of these tile sheets with, like, I'm sure there's some with thousands of elements in them. Why would you choose to make your selector a single column like this? Just what a pain in the neck to use. So for in the documentation, there's a couple of lines that say, like, you know, about this animating tiles being one of Mappy's greatest features, which I don't doubt it. I just think that their interface is just sadistic, almost. Anyway, so you set that to make your reference image, and when you use the insert button, that's when you're actually picking, okay, I want you to animate this tile first, then this one, yada yada yada. You hit OK, and then you have these two additional settings to set. So this is the delay I was talking about earlier. I wanted it to be half a second. I think this is what, 30? Yeah, the delay would be 30. So every 30 frames I want you to switch. And then this is kind of like the direction or the function of the animation. Loop for not loop forever. Loop forward, loop reverse, do it once, and I didn't mess around with these last three. So that's animation, and let's look at the user data. So the user data is what those friend functions were grabbing, and they were returning the true or false, whether you got a 7 or an 8 or a 9. So 7 was for advancing to the next level. We'll take a look at the second level real quick. And that one was set to this ladder tile here. So I'll go here and I'll double click this ladder. And you can see it has a 7 on it. So that's how you advance through the levels. And for the last map, let's open that, level 3. That was the little tomatoes there. They have the 9. So they return, oh, that's not necessary. But so user 1 returns that 9. If it matches, go ahead, true, and then that's how the game ends. Now, one other thing that I wanted to kind of show here, and that's to demonstrate the power of this FMP file, is the tile set and the actual coding of the map are bundled together and saved as an FMP. So you don't need to store this file set in your program file at all. It's already embedded in there, and that's neat because I was going through these maps, right? So obviously I made map 1 first, and I made some kind of modifications to the tile set. So you can see that there's a green background here. I did some other stuff, but that was to aid in this animation here. Originally, there was only one set of peppers here. There was another, I don't know, artichoke or something. And so I wanted this to be a dangling pepper. So I cut this thing out in GIMP and pasted it back here, and then I just used a horizontal flip so that I could give this dancing illusion by just flipping back and forth between these two tiles. When I go on to like another level, I did similar kind of modifications, and let me show you. If I import the very last version of my tile set, what happens to the main map here? You see, it's all blue around the edges here, and that's because when I edited the tile set for, oh man, it's gonna make me look for this thing. Okay, hang tight. This won't take very long. There you are. When I was editing this one, I for some reason they had like a weird background for these lily pads, so I put them to blue, and the bridge had some other thing behind it as well, which was annoying. So I wanted to kind of get it to match up properly. So I made those changes to it, and you can see it's just easier to take a little bit of blue and then blow it up, and it obviously bled over into some tiles, some dark, here you go, the dark green tiles. So as I was just kind of arbitrarily brushing the blue where I wanted it, I hit those tiles. But it doesn't matter, because the imported tile set is like a copy is saved to it and then bundled in with that FMP. So I just wanted to make that discovery clear in my video. I think that pretty much wraps up everything that I want to discuss in this video, and I thank you for watching this, and I really hope you enjoyed it. And if you did, hang tight. In just a couple of days there will be my final project, which will pretty much build on this, and hopefully it'll seem like a more complete game. So thanks again for watching.